Hello, all. Welcome to the series of talks about Rust. In today's talk, we are going to explore the interoperability of Rust with C. Specifically, this talk will be targeted towards how we can call C function or a statically compiled C library from Rust. So, I've created this agenda. We'll be covering what interoperability is, its advantages, what are bindings, then bindgen cret, then creating how to create a static C library, then how to create the bindings of that static C library, Rust bindings. I should call them Rust bindings. Okay. Then calling C functions from Rust code and creating static library from Rust code and then calling Rust code from C. So for the reference, I'm just referring to this embedded Rust book. I found this very useful, and rather than creating my own material, I thought of just walking through this thing. So let's get started. The first point it says is before consuming C++ code from Rust, it is necessary to define what data type and function signature exists in the linked code. That is, whatever structures and data types you have in your statically compiled C file. Those things we need to create in Rust first of all in order to call the functions or use the structures and functions from a static C library. So there are two steps to do that. One thing is we can do it manually, and other thing is we can do it by using this bindgen crate. So rather than going towards the manual process, we'll directly jump onto the bindgen crate. Now, what is this bindgen crate? Uh, we'll have a look. We have a very good user manual also for this bindgen. So this bindgen is nothing but a crate which helps us to create a Rust bindings. The Rust binding is nothing but representation of our C structs and function in our Rust code. So those are nothing but our Rust bindings, and rather than doing it manually, we can use this bindgen crate to create bindings for us. How to do that? We will see. So it has got a very good tutorial, and I would suggest please go through this tutorial for at least first three chapters for everyone who wants to explore Rust or rather embedded Rust. So we'll start with a basic C code. Mm, okay, before coming to actual code, maybe we can talk about advantages of interoperability in Rust. So, what will be the advantage of interoperability? The one thing, the straightforward thing is what I can think of is you don't need to write legacy code from scratch. If you have something which is working and which is error free and which is being tested over several days or several years, we don't want to touch that thing. Like the programmers say, if something is working, don't touch it. So if something is already working and well tested in C, we are not going to touch that thing, and we don't want to rewrite that thing in Rust. So it's better to write only specific code in Rust, which is which have your memory safety related bugs or which is dealing with buffer overflows and all, which is having all those problems. Only those part of your project will be written in Rust. So in this case, this interoperability will play a very major role. Also, I do have an example of my NRF 91 board. For this board, we in this board I have a crypto cell accelerator, that is CC310 ARM crypto cell. So ARM is creating their static C or they are creating the C library for this crypto cell, and they are shipping it with their SDKs. So I don't want to write that static C library again. I just want to call functions from that static C library and make use of my crypto cell accelerator. And that is how I have demonstrated my capabilities of crypto cell on NRF 9160s. So these are a couple of advantages of interoperability with C in Rust, and also it is very simple and very comfortable to use. We don't need to do much things. So we'll see down the line what all things are required. So let's suppose now let's dive into the code. This is my C code which I have written and which I am thinking of creating a C library or static C library for this code, and we are going to call these functions from our Rust code. So here I have defined my struct, let's say a referral struct. Then my referral will have a name of 20 characters. It has an age of integer type. It has a pin code of residence of integer type, and it has a salary of float. Then this is my function, which is adding referral to a particular file. That is registration.txt file. And here I'm just comparing if the referral's age is less than 18 and it is greater than 30, then I'm not going to add that referral, and some other condition also. So depending on that, I'm adding my referral to this .text file. Okay. Now let's create a C library or a static C library from this code. So we'll just open a terminal over here. We'll compile this thing first. gcc-c registration.c-o registration.o. So I can see my registration.o file is been generated, and now we will create a static library. So rcs, this is the code to create a static, this is the command to create a static library. Let's give the name of your static library lib registration.a. Then you need to provide the name of your compiled file, registration.o, and here you have created your lib registration.a, that is a static C file. Now we are going to use this file in our Rust code. So let's create our Rust code from scratch. Okay, let's create our Rust code. So I do have here Rust code already created. We'll clear the things and I'll show you from scratch. So first of all, you need to bring your library file over here, and okay, let me clear some of the things. Maybe we don't need this thing. And now I'll delete this. Let's open a terminal over here to cargo clean, and I'll delete my previous files from here as well. And this is my build.rs file, and this is my cargo.toml file. Okay. So let's start with our cargo.toml file. So here I'll tell you only we are going to use bindgen, nothing else. Now what is bindgen? This is the introduction to the bindgen, and we'll just follow the tutorial steps. So we have to include bindgen as a dependency in our build dependency section. So we have included that with the latest version. Now this, as this is our build dependency, we have to call this thing in our build.rs file. And in build.rs, here you have to mention the path of your statically compiled file or static C library. And here in this line, like you have to mention the name of your static library. So here in this, the name of our static library is, if you go to C program, and here is my .a file, lib registration.a. I'll copy this file and I will put this in my Rust program. And if you go to Rust program, so here is our the name of our static file. Now there is a trick over here. uh, while defining the name of our static library, we don't need to add the lib keyword. Just add the name excluding that lib keyword. The lib, it will add from automatically from its side. Then what is wrapper.h? We will come to that. Okay, let's look at the wrapper.h. So for creating the bindings, what we have to do, we have to create, or we have to collect all the .h file, that is the header file, under some folder. Let's suppose I have given that folder name as a bindings. In that folder I have collected my .h file. Now .h file is nothing but I don't need to tell you about .h file. This is my .h file in C. I've just copied that file and taken into my Rust code. And then you have to write your wrapper.h file. This file name can also be different. It doesn't have any rules that it should be wrapper.h only, but it should include your all the header file. If you have multiple header files, you can include them right here, like this. My header file.h. Since I don't have any other header file, I just have only one header file, but all the header files, whatever you have for a particular static library, you can include them over here. Then coming to the build.rs. So the first thing we have defined, we have told cargo that, hey, listen, this is the path where is our static library present. So I guess the path is correct. Rest program. Okay. Then we have told the name of our static library is this, excluding the library. Then here we have added the name of our wrapper.h file, the relative path to that. Then this is how we create the bindings. We are creating the bindings instance first of all, or maybe bindgen instance. So what all things we have to provide? We have to provide the header files, that is our wrapper.h, callbacks, cargo callbacks. Then we are calling generate on it, and this is to expect if there is any error. Once we get uh, once we get the bindings, we uh, we are writing that binding to our out directory. Now this out directory is situated at our target folder, target release, and there is our out directory. And we are writing that binding to a particular binding.rs file, so that it is accessible to our linker for linking our static C code. So this is a very basic example of build.rs file for a static C file, for including a static C file and creating a bindings for a static C file. Now coming to our main program in Rust. So this is how we can include our binding.rs file, like include concat environment name, out directory, and binding.rs. So this what this will do, um, it will include all the things from that binding.rs into our code. So let's take an example. First of all, I'll comment all this thing. I'll just keep hello world and this thing, and let's see what how the bindings are created and how does it looks like. So we will do cargo build release. Let's see, let's go to target folder, release, build, and if we see our Rust program, hmm, this is the out directory, and here is our binding.rs file. So if we have a look at this binding.rs, let me pull this up. So this is our binding.rs file, or this is nothing but our bindings, Rust bindings for our C static library. So see here we have our um, Rust style representation of our C struct, as we have seen here in the manual section. If we go, yeah, wrapping C functions. So this is how they are wrapping their structs and C functions in the Rust file. The only difference is we have used this automatic procedure to create the interface. Now let's ignore this test file, and this is our extern C function, or the function definition. So yeah, that's all about the bindings. This is the binding which we wanted, and with this line we have included those bindings in our main code as well. So now in order to call those bindings, I am defining this string. I'm using my name only. Now you have to see if my string length is less than 20, because in our static library we have defined the character length of 20 only. And then this code I have written, which iterates over the characters and creates an character array of my string. Finally, in the referral, here we are calling our foreign function. We are creating the referral struct with name character, which is nothing but this is the array of I8 of 20. Then age is 30. Then my pin code, my salary, and finally we are calling the function. And yeah, calling any foreign function needs an unsafe block, because that's in static C library. Rust has no control over that function. That's why we have to call it from an unsafe function. Okay, now I think most of the things are in place. We'll compile this code, see if this code compiles. Do clear first of all, and cargo build release. Yeah, I think it's built. Now we'll just do cargo run. So yeah, hello world is printed. That means we must have, yeah, here is our registration.txt, and here is my name in that. Maybe we can do it one more time with some other name. Let's suppose yeah, any other name. Uh, okay, Alexander. Alex. Uh, Philip. I don't know. And let's try this again. Hello world is printed, and Alex Philip is also printed. We don't have an carriage written over here. Let's try with this new name, Andy Flower. Okay, Andy Flower is again added here, but now I guess the new name will be added in the carriage return. Yeah. So this is how we can call our static C library from our Rust code. Then we gonna see creating static library from Rust code. Okay. Now it's the another way around. If you already or if you want to write some of the C code or existing code in Rust, which we think would be beneficial for the project, we have written in Rust, and now we have to call those Rust APIs from our C function. So in order to do that, there is not a much big deal. It is just like once we create a static library from Rust, then that static library can be imported in a C function as good as good as it is a C static library. For example, here in our code, in this code, what I have done is I have created a static library and I have called that static library from my main.c in this way, included registration.h, and then I have called my static library add referral from here. So on the similar lines, once we get this .a file from our Rust code, it is very easy to call our Rust code from our C file. So let's see how we can compile our Rust code into static library. For example, let's take an example. Let's say this is not a main file, this is a library file. So if we rename this thing, mm, rename, I'll say it as a lib. There is no main over here. I'll say this add referral, and what is the error over here? Add referral is multiple defined. So I'll say Rust add referral. Let's clear all these things. I'll just print here something. For just an example, I'll say referral added, and I don't want to use bindings over here, and in the cargo.toml bindgen is not used because now this will be acting as our static library. So in build.rs we don't need all these things. In fact, we don't need build.rs itself. In cargo.toml, what we have to do is we have to specify here this thing. For example, yeah, library, name of our library, and how are we going to. So this is the example of C dynamic library. If we want to create a static library, then we have to give here name static lib like this. Yeah. So the name of our crate referral static lib, and I think things should work now. I'll do cargo clear, cargo build, release. Yeah, we have got our the program is compiled and our library file must have been created in the release folder. This is our library file libreferral.a. Now this library file we can hand it over to our C code, and we can call our functions from C code or Rust functions from our C code. So I think we have covered all of the things which we have in or which we had in today's agenda. So I think that's all for today's session. And please, if you have any questions on interoperability of Rust with C, or interoperability of Rust with Python, interoperability of Rust with any other language, um, please add your comments in the section, and then we'll discuss, or maybe we can have a healthy conversation about that. Okay, so for today, that's all. Thank you. Goodbye. Have a nice day.